Our third shuffle is Shuffle 39. It's also a judicious Klondike, but this time we're stacking from right to left in sort of a leapfrog fashion, as we'll see. Okay, so what we do here is we begin with our ordered packet, as always, 1 through 8. We perform our shuffle and then record the new ordering of the cards. So how this works, the judicious Klondike, you take the top and bottom card off as 1 and set that down as pile 1. The top and bottom card off as 1 into a second pile. Top and bottom off as 1 into a third. The last 2 cards become pile 4. The stacking is as follows. Pile 4 gets stacked on top of pile 2, so you can think of it as leaping over its neighbor. And then pile 3 gets stacked on top of pile 1, so it leaps over its neighbor. And then we're stacking the right pile on top of the left. So what is the new ordering of the cards? Let's take a look. So we obtain the following. 4, 5, 2, 7, 3, 6, 1, 8. So expressing this in Cauchy's 2-line notation, we obtain the following. The top row is always 1 through 8. The bottom row is 4, 5, 2, 7, 3, 6, 1, 8. We can convert this to cycle notation as follows. 1 goes to 4, so there's an arrow from 1 to 4. 4 goes to 7, so there's an arrow from 4 to 7. 7 wraps around to 1, so that completes a 3 cycle. 2, where does 2 go? 2 goes to 5, so there's an arrow from 2 to 5. 5 goes to 3, so there's an arrow from 5 to 3. And then 3 wraps back around to 2, so that completes a second 3 cycle. And then we get a couple of fixed points. 6 goes to 6, so we can write that as a single cycle, or a 1 cycle we call it. And also 8 goes to 8, which is a second 1 cycle. Now remember, in the cycle notation of permutations, we typically do not include the 1 cycles, as long as we are clear on the size of the set that we're working with. If we know that we started with originally 8 objects or 8 values, then we can safely drop these. So any numeral between 1 and 8 that's not present is assumed to be a fixed point, which they are, 6 and 8. And being a fixed point, what that means then is what began in position 6 is returned to position 6 once this shuffle is complete, and the same is true for position 8. And color-coded, we obtain the following representation. Recall that position values 1, 4, 6, 7 are color-coded black, and position values 2, 3, 5, 8 are color-coded red. This will help us keep track of what happens to the underlying Bessey sequence structure. So in particular, we see that the black 1 goes to the black 4, which goes to the black 7, which wraps around to the black 1. Red 2 goes to red 5, which goes to red 3, which wraps around to red 2. Black 6 goes to itself. Red 8 goes to itself. So we can see here that each value gets sent to a value of the same color. And when that happens, we say that the Bessey sequence structure has been preserved. So what that means then is all of the cards that began in positions 1, 4, 6, 7 end up in positions 1, 4, 6, 7 after the shuffle is completed. And the same is true for the cards in positions 2, 3, 5, 8. They will end up somewhere in these same positions after the shuffle is complete. And we represent all of that by the following set of symbols. So this means that inversion has not occurred. So in particular, it means that if we begin with this Bessey sequence 1, 0, 0, 1, 0, 1, 1, 0, and perform this shuffle, we should get that sequence form back. So remember, the judicious Klondike, we're taking the top and bottom card off as 1 and setting that pair down as pile 1. Top and bottom off as 1 into pile 2. Top and bottom off as 1 into pile 3. The last 2 make up pile 4. The stacking is the 4th pile gets stacked on top of the 2nd pile. The 3rd pile gets stacked on top of the 1st. And then we're stacking the right pile on top of the left. And so we should get back to 1, 0, 0, 1, 0, 1, 1, 0. Taking a look at the shuffle diagram for shuffle 39, we can see that the fixed points 6 and 8 are represented as single dots with no arrows. Though you could have a circular arrow that starts at 8 and returns to 8, the same thing for 6. And then the first recycle is 1, 4, 7. So this means that if we start at 1, there should be an arrow from 1 to 4, which there is, and then an arrow from 4 up to 7, and then an arrow from 7 to 1, completing that 3 cycle. This also means that the values 1, 4, 7 constitute an orbit, or constitute their own orbit, since those 3 values just move around among themselves each time this particular shuffle is performed. Taking a look at the second 3 cycle, we see that 2 goes to 5, which goes to 3, which returns back to 2. So if we come down here to 2, there should be an arrow from 2 down to 5, which there is, an arrow from 5 up to 3, there it is, and an arrow from 3 to 2, completing that 3 cycle. Those 3 values also constitute their own orbit. And I guess I should point out that value 6 constitutes its own orbit, and value 8 constitutes its own orbit, since objects in those positions don't go anywhere. There's also a note down here below that shuffle 39 is identical to shuffle 34, which we saw earlier in the series. So let's take a look at that. So here is shuffle 34, and it also indicates that it's identical to the one that we just showed you, shuffle 39. And you can readily see the equivalence of those shuffles by just looking at their diagrams. The diagrams are identical for shuffle 39 and shuffle 34, and the arrows are pointing in the same direction as each other. Now, remember here, the alternate Klondike, this is where we perform the Klondike shuffle, but it's a left, right, left, right, and then here we're going to stack the right pile on top of the left pile. Okay? So what we have just seen here is that that set of actions, or that shuffle, is equivalent to the shuffle that we just performed, shuffle 39. And it would require a little bit of detective work to perceive that those are indeed equivalent sets of actions, leading to the same permutation of the cards in the end.